This is the video for Accelerated Geometry on Section 8-2 on data gathering. Key vocabulary in this lesson is population, census, sample, random sample, bias sample, statistic, and parameter. The essential question for this lesson is how do you use random samples to make inferences about a population? Surveys are often conducted to gather data about a population. A population is the entire group of people or objects that you want information about. A census is a survey of the entire population. When it is too difficult, expensive, or time-consuming to conduct a census, a sample or part of the population is surveyed. When every member of the population has an equal chance of being selected for a sample, the sample is called a random sample. Or probability sample. Random samples are most likely to be representative of the population and are preferred over non-random samples such as convenient samples or self-selected samples. A non-random sample can result in a biased sample. A biased sample is a sample that may not be representative of the population. In a biased sample, the population can be underrepresented or overrepresented. Underrepresented means that one or more parts of the population are left out when choosing a sample. And overrepresented means a greater emphasis is placed on one or more parts of a population when choosing a sample. Random samples are less likely to be biased, while non-random samples are more likely to be biased. Bias in samples is not always obvious at first glance. A statistic is a number that describes a sample, while a parameter is a number that describes a population. And the way you can remember that statistic goes with sample and parameter goes with population is statistics and sample both start with an S, and parameter and population both start with a P. You can use a statistic from a survey to estimate a parameter. In this way, surveys can be used to make predictions about the population. Example 1. A researcher is gathering information on gender of a prairie dog at a wildlife preserve. The researcher samples a population by catching 10 animals at a time, recording their genders, and releasing them. How can you use this data to estimate the ratio of males to females in this population? First thing we're going to do is find the total number of males and the total number of females. So if we take 5 plus 7 plus 4 plus 18, we know that there were 24 males in the sample. While for females, 5 plus 3 plus 6 plus 2 would give me 16 females in the population. In the sample. So since there were 24 males and 16 females in the sample, he can estimate that the ratio of males to females is 24 to 16, which reduces to 3 to 2. Example 2 says a car factory just manufactured a load of 6,000 cars. The quality control team randomly chooses 60 cars and tests the air conditioners. They discover that 2 of the air conditioners do not work. Identify the population in the sample. So our population would be the 6,000 cars that the manufacturer produced. And then the sample would be the 60 cars that had their air conditioners checked. Example 3 says decide whether each sampling method could result in a biased sample and explain your reasoning. A says a survey of city residents is conducted by asking 20 randomly selected people at a grocery store whether the city should impose a beverage tax. We would say that this example is biased because the residents who do not shop at the store are underrepresented, so you do not have a good true representation of the entire population. Example B says a survey of students at a school is conducted by asking 30 randomly selected students in an all-school assembly whether they walk, drive, or take a bus to school. In this example, no group is either overrepresented or underrepresented, so this sample is not likely to be biased. Example 4. An online news site asks readers to take a brief survey about whether they subscribe to a daily newspaper. Decide whether each sampling method could result in a biased sample and explain your reasoning. So in this example, it would produce a biased sample because people who are visiting a news site online are probably more likely to be interested in news and subscribe to a daily newspaper. Example 5. A car dealer wants to know what percentage of the population in the area is planning to buy a car in the next year. The dealer surveys the next 15 people who come to the car lot. Are the results of the survey likely to be representative of the population? Well, if you think about this, since the car dealer is asking people that come to their car lot, this is a convenient sample, and convenient samples are not completely random and therefore are probably going to produce a biased sample. So we would say that the sample is a convenient sample, which is not likely to be representative, and people who come to the car lot are more likely to be planning on buying a new car. Example 6. A restaurant owner wants to know how often families in his area go out for dinner. He surveys 25 families who eat at his restaurant on a Tuesday night. Are his results likely to be representative of the population? And explain. So in this example, we would say no, it's not going to be representative of the population because again, people in a restaurant on a Tuesday night are probably likely to be eating out. So if he's surveying about how often they go out, if you're asking people who are out to dinner, then they're more likely to be ones that actually go out to eat. Example 7. In a random sample of phone calls to a police station, 11 of the 25 calls were for emergencies. Suppose a police station receives 175 calls in one day. Predict the number of calls that will be used for emergencies. So in this example, when we're trying to make a prediction based on a sample that we have, what we'd do is we would set up a proportion and cross multiply to solve. So the proportion that we're going to set up on this is that the emergency calls in a sample over the police station calls from the sample is equal to the emergency calls in one day over the police station calls in one day. So according to our problem, it says 11 of the 25 calls were for emergencies. So 11 of the calls in the sample were for emergencies out of the 25 calls that were made in the sample to the police station has to equal, we're solving for the number of emergencies in one day, given that they had 175 calls in one day. So when we cross multiply here, we get 25x equals 11 times 125, or 175, is 1925. And then we're going to divide by 25 to get that x equals 77. So what this is saying is that you can predict 77 emergency calls in one day. Example 8 says the manager of a store randomly surveys 20 customers. Of the 12 staff members, 3 had shifts on the day of the survey. Of the 20 people surveyed, 15 thought the staff was not attentive enough. The manager decides to choose the store for a day and hire a consultant to come in and train the whole staff on customer service skills. Did the manager make a good decision? Why or why not? So before you answer the question, you really want to know, was his sample a representative sample? So if he has 12 staff members and only 3 were working that day, and he surveyed 20 people and 15 thought that they were not very attentive, were the 3 that he had working that day really representative of the 12 members that were on the staff? And the answer to that is no. So because of that, he didn't make a good decision. So we would write something along the lines of the manager did not make a good decision. The sample was taken from customers who may have only had experience with 3 of the 12 staff members, so it's not a representative of the entire staff. Last example says that a promotion in a cereal box says that 1 in 4 boxes will have a prize inside. Marion has bought 5 boxes but hasn't opened a prize. He decides that the advertised prize rate must be wrong. He justifies this evaluation. Or is he justified in this evaluation? What are the chances to the nearest percent of not opening the prize in 5 boxes? So the first thing that we have here is that the chances of winning is 1 in 4, which is 25%. So if the chance of winning is 1 in 5, or I'm sorry, 1 in 4 is 25%. So if the chance of winning is 25%, then the probability of not winning would be 0.75 because this is the complement to winning. So 1 minus 0.25 would be 0.75. Well, we want to know what is the chances of not winning in 5 boxes. So we have not winning intersected with not winning, intersected with not winning, intersected with not winning, intersected with not winning. And this is an and statement because you're not winning and not winning and not winning and not winning and not winning. So we're going to multiply here. So the chance of not winning is 0.75. So 0.75 times 0.75 times 0.75 times 0.75 times 0.75 would give us 0.24. So the chances to the nearest percent of not opening a prize in 5 boxes is 24%. So is he justified in his evaluation? And the answer to that no, he is not justified in his evaluation because the sample size was too small. He has about a 24% chance of not opening a prize in 5 boxes. So when you think about having the chance of opening a prize in 4 boxes of being 25%, then not opening a prize in 5 boxes is 24%. They're really, really close together. In order to really justify his evaluation of whether or not the cereal box is advertising correctly, he would need to do a much larger sample.